Hello, everybody, and thank you, Steve, particularly for inviting me up here, and to Ewan for fixing my presentation just a few minutes ago, and also thanks for Rob for that excellent segue into my presentation. We had a good question from Sigurd down there regarding spoofing of position reference sensors, and I'm about to talk about a whole new suite of position reference sensors that's coming onto the market, and how we're handling them, from a DP perspective, and how they can add value. So just a quick bit about me. Andrew Stead, Business Development Director for Navis Dynamic Positioning. I used to work previously for Sam Electronics and Sperry Marine on the navigation side. I'm looking forward to speaking to Faruno later on at their booth. But before that, I used to work as the sales director at Guidance, who I think a lot of you will recognize as the manufacturers of the SciScan and the Radiscan systems, which a lot of you are familiar with. We'll perhaps talk a bit about those later. What are we doing? So Navis manufacture a dynamic positioning system, and the thing that's happening in the market is a lot of funding and money is going into the autonomy sector, both automotive and naval. And so we're seeing a whole suite of new sensors and new development technologies coming out now that are driving this autonomy space. And that is going to impact here on the oil and gas. It is impacting on position reference sensors that you're using in your day-to-day life. And because it's a new suite of sensors coming along, it brings in some great new benefits, but also some risks and some safety issues that we need to be aware of and we need to make sure we address, and that we as a DP manufacturer are responsibly addressing and familiarizing ourselves with. Short bit about Navis DP, based in Helsinki in Bulgaria. DP systems make up about 80% of the business. Understand the sensor inputs in depth is part of our core philosophy. And if there's one safety message I'd like to communicate to everybody is if you have sensors on board your vessels, it's super important to make sure you understand their behaviors in depth. Attended a very good meeting yesterday from the Hydrographic Society about GNSS spoofing. It happens, it's real, but if you really understand your antennas and your sensors, you're in a much stronger position to recognize it when it's happening and mitigate it best you can. Also, a quick shout out to Sonodyne, who are going to facilitate the trial that Navis are doing over the summer. So basically, over the summer, we're going to be doing a whole series of trials, testing a load of targetless sensors. Sonodyne are providing a vessel. Thank you very much to Sonodyne. I know this isn't a big sales spiel for them, but one thing I like about them, and I like it about a lot of companies in the oil and gas business, is they're a company prepared to invest in core research and development. And I think that's so important for all of us in this business, because sure, we're all here to make some money and we're all here to do some commerce, but at the end of the day, we've got to do it safely and we've got to all go home at the end of the day. So it's good to be working with colleagues who are interested in really understanding the depth of the way in which these sensors work. And they're supporting the trial with a vessel, so I thought I'd give them a quick shout out. I wasn't sure about the audience today, so I've got a slide, a quick primer on DP sensors and what they're about. Most positioning of vessels is done, as you'll be aware, on GNSS or GPS for those who are less familiar with the GNSS acronym. But if you imagine a relatively small platform supply vessel, and I know they look huge in the harbour when you're standing against them, but up against a drilling rig or a platform, they're tiny, and when they come up against them, particularly here in the northern latitudes, you get a lot of multi-path reflections where the GNSS signal is being reflected and giving you a false position. There's no spoofing involved, there's no maliciousness involved, it's just the physics of a small signal coming down from outer space, and it can move around. And I think if you're pumping drilling mud for 48 hours next to a hydrocarbon riser, you don't really want to be moving around on your GNSS. So as a consequence, some other modalities have been developed, and you'll all be familiar with taut wire and with some of the sonar, putting sonar beacons down in the water, and of course on the surface ones, the ones I've been involved with previously, laser and radar, sending out energy onto the asset and getting a reflection back from a target. And all they do is go round and round, they send out the signal to the asset, they get a reflection from the target, and they measure a range and bearing to that. And to date, these have all required targets, measuring range and bearing. The new generation are all targetless. And you might have seen pictures of Waymo cars going around in San Francisco. They've all got LiDARs and radars. In fact, most of you have probably got a radar on the front of your vehicle. It'll be a static radar just looking forward and making sure you're not going to bump into the vehicle that's in front of you. But the next generation are going to be dynamic. They're going to be dynamically steered, and they'll be looking around your vehicle. And those technologies are being driven by the automotive industry. Huge amount of money going into it. So the sensors are being developed. The chipsets are being developed. You know, we've all watched NVIDIA become the most expensive business on the planet. All of that is developing the same technologies for processing this sort of data. I've just got a photograph there of a jack-up vessel. I picked an extreme photograph from Yandanul. Just to give you an illustration of sometimes how difficult it is to fit targets onto assets. If you try mounting a target there, it's difficult to get it at the right level. You have no idea. And then the level will change depending on what the tide's doing and so on and so forth. That brings me to some of the problems with targeted sensors. Here's some illustrations of some of the retroreflective laser targets that exist. Firstly, you've got to have a target on an asset, and a lot of assets are normally unmanned installations down in the southern North Sea, often don't have any targets fitted. Then the vessel's got to approach the asset without a target, without any positioning, do a handover of a target. Then they've got to have them installed at the right location. They've got to be fixed. Nobody's got to walk off with them. You get target occlusion issues where you're pumping drilling mud and the hoses are swinging in and out of across the target and you're losing sight of the targets. Target degradation, where you put them on unmanned installations, they're not maintained and they get guano buildup, they get salt riming buildup, and then they lose reflectivity and so on. If you've got radar targets, you need batteries. If you've got sonar targets down on the seabed, again, they need power going to them. And then target movement. Sometimes, as in the previous photograph, if they've hung them from a jack up on a rope, they could be swinging around, or very often the movements from the vessel itself. If you're in a high sea state, your vessel's moving around, your sensor is moving around, and it may or may not lose sight of the target, and then you lose your positioning. So, and then you've got target confusion. I could go through the whole list. But the important thing is all of the above requires the DPO to satisfy themselves. Part of your process is for the DPO to go out there with the binoculars if necessary on a dark and rainy night out on the bridge where they don't want to be, where we as a safety group don't want them to be, and they've got to satisfy themselves that they are locking onto the correct target and holding position like that. Targetless offers the opportunity to get rid of all of that. And we'll come on to that in a moment. There's also some cost issues, and I know this is a safety forum, but I don't think you can quite disassociate cost with safety. If it costs more, people tend not to do it, and then you lose the safety side of things. On the contractual side, you've got the question of who's responsible. Is it the asset owner or is it the vessel owner? Who's going to maintain them? And it's okay in the oil and gas market where perhaps you've got one target on one asset and it's being supported by 4 or 5 vessels. That's a nice cost-effective ratio. You take that to a wind farm where you've got 120 wind towers, all with perhaps 3 landing stages, and you've got only one platform supply vessel, and it becomes a whole different ball game altogether. So I think there's a lot of benefits and a lot of industry pull for targetless as a solution, but it's a new technology. We've got to familiarize ourselves with it. It brings risks. So this is just, and this is not a complete list. I know there are other sensors, and you're very welcome to come up to me afterwards and talk to me about any sensors you're looking at. I'm always interested in understanding the full size of the market, and I know the Chinese are bringing out some interesting sensors, so it's watch this space. It's going to be changing significantly over the next few years. Some of you may be familiar with the scene scan. I think that was the first targetless laser sensor out on the market, and there's a few more there that have been brought onto the market. We're going to be testing next week the Furlong Unity, which is a very interesting multi-point laser, which we're going to be looking at. I know that Guidance, who currently have a very good targeted radar system, are bringing out a targetless radar. And I know that's going to be particularly interesting to the industry because maintaining radar targets is an absolute nightmare because they've got to be powered and they've got to be maintained. The maintenance of them takes a lot of time, and they're significantly more expensive than the retroreflectors for lasers. And then, of course, we've got the sonar, and Sonodyne have got a very interesting product, which is a targetless positioning system. It doesn't do it relative, other than relative to where the vessel is. So you can zero where you are in the vessel, and then from that point on, it will measure where you are relative to where you zeroed. So it's a very interesting solution to spoofing and other things like that. So what are we going to be looking for? Well, we've got to be a little bit careful because the sensor manufacturers themselves have done their own tests, and I don't want to repeat those, but I do want to satisfy myself as a DP integrator, as somebody who's selling a full DP solution to you guys. I want to satisfy myself that what they're claiming is true, and more importantly, what are they not claiming? What are they not telling me about? What are the gaps and issues that... These are all new sensors that are coming out. They are very clever sensors. They do a lot of very good things, but for sure, we are going to uncover some weaknesses that we need to understand and know about in order to work with these sensors in a safe manner. I'll just give you an example of that. On the laser sensors work by basically sweeping the asset with a point beam of laser and using the natural reflectivity of the asset to get a point cloud. And then they do one scan, and then on the next scan they match that, and then they shove that through the NVIDIA fast Fourier transform chips that map it all together and tell you where one scan has moved relative to the next. But what do you do if there's a black body? For example, I know the Penguin FPSO is, I believe, a circular FPSO. It's a very black FPSO. It's a tricky one to get a natural reflection from, so how would it work against something like that? Or, for example, we call it scene scale occlusions. So you've got, generally out there, you've got a platform and you've got a vessel, and that's happy days because there's only the platform to look at, so it's not going to get confused. But what if that platform has a giant construction rig right next to it? And when you go up there, you automatically scan the construction rig and the platform at the same time, and the construction rig happens to account for more than 50% of the scene, and the construction rig happens to be about to depart. Then how do you handle that? How should we as a DP operator communicate that risk to the DP, as a DP integrator, communicate that risk to the DP operator? And these are things we're looking to explore with these trials. Extreme vessel motion. I know there have been incidents in the North Sea from extreme vessel motion where the vessel has lost sight of a target through movement. We believe that the targetless solutions will behave much better, will be much stronger in that state, because essentially the whole asset is their target, so they've got a much wider field of view. But we don't know that, and what we need is more real live data, and we need more information ourselves. And again, how do we communicate that through the integrated DP system back to the DPO that maybe they're losing sight of their entire scene, and therefore they need to review it. So extreme vessel motion, I've put there closing circular vessel routes. One of the really interesting things is very often you go to a crane to offload, then the weather changes or the tide changes, and you need to go around the other side to offload at the other crane to make the most, to stay on the lee side of the asset. The new targetless sensors hold out the possibility of never coming off DP and never having to select a new datum point. You go up there, you select your datum point, you start offloading at one crane, the weather changes, you need to move around to the other crane, and all you do is instruct your DP to take the vessel around to the other crane. You don't need to change targets, you don't need to change anything in the setup, because what's happening is the sensor is essentially mapping its way around the asset and building up a map of the asset. But what happens when you go all the way around? You'll understand that as you move around the asset, you're slowly building up errors bit by bit. How far can you move before you actually have to reset your position? What happens when you go all the way around and then you try and map where you were to where you've arrived? And then again, for some of the subsea targetless sensors, high current locations, distorting acoustic references in the water column, immunity to waterborne noise. I'll say it over and over. The best way to stay safe in a dynamic positioning situation is to really understand your sensory input. Understand your GNSS and how it can be spoofed. Understand how your individual sensors work. Every single one of those sensors on that, every single one of these has its own strengths and its own weaknesses. And very often in the sales pitch, people don't want to talk about the weaknesses, so you've got to learn those separately. And maybe it's actually something the Marine Safety Forum could get involved in, is to provide a forum whereby some of those mitigations of those weaknesses can be shared, and we can make sure that we're in a stronger position. Going backwards. Let's go forward. There are some benefits. I've spoken about benefits of targetless position reference sensors. One of the things I find fascinating is that you get a lot of situational awareness. These are scanners that are scanning for a laser, they're scanning the near side, they're scanning the whole asset. For a radar, you're getting a much wider field, but in fairly high resolution. Can we do anything useful with that data? And you can see here on the right a little test we've done with the Furlong Unity, taking the scanned laser data, flattening it into a plan view, and putting it onto our own DP interface, our own DP HMI, and I suppose the question I'm asking of the DP community is that interesting? Is that useful? Previously and currently on the Navis DP, and I'm sure for all the other DP operators, integrators out there, the other DP systems, at the moment this doesn't happen. At the moment all that happens is a range and a bearing, and you end up with a spot on your DP plan which shows you where the target is. But in a targetless environment, we can show the millions of spots that are scanned, if that's of interest. It promises the possibility of putting electronic guardrails up. Once we've scanned an asset with a laser, we can then theoretically, if the industry is interested and if we think it can add value, we can bring that into our DP system at the moment. That's something we can do right now. But then we can put an electronic guardrail around that scan and say, well, we want to keep the vessel outside of 20 meters from that asset. You put a 20-meter guardrail on there, and then the DP can be set up to make sure that no part of the vessel incurs within that 20-meter guardrail zone. So these are quite exciting, interesting new safety techniques that can come from these technologies, but it needs the industry and ourselves to drive it forward, and that's part of what we're trying to do here in this presentation and during our trials. This bottom one, this bottom picture here is from the scene scan, and those of you who are familiar with scene scan will know that it's actually just works in 2 dimensions. It just does a single scan, and you just get the 2 dimensions. You don't get as much of a rich data set as others. What you may not realize is that before it sets up, the first thing it does is scan the whole asset top to bottom. So right at the outset, it's already got a full scan of the asset, which we could bring into the DP if we wanted to. What's interesting is the sensor manufacturers have come out with these targetless sensors, but the DP integrators are treating them as targeted sensors. So one of the interesting things is that with targetless, you get relative heading. So just a short aside for those who are unfamiliar with the DP world, having range and bearing to a target is perfect where you have a fixed platform on the seabed. When you have a moving asset, like for example an FPSO, that could be weather vaning around its hydrocarbon riser, then you need to move your vessel with it. You need relative heading. And historically, that has meant with targeted sensors, you've had to put 2 targets up on the asset, and then that's actually how SciScan got its first big break, was in the Brazilian market. It was up against an established technology, and because it had a turret design, it was able to sweep through 2 targets and report back 2 range and bearings. But historically, the integrators have always just used those range bearing to a target messages. And to get relative heading, we actually ask the targetless manufacturers to give us 2 range and bearings to 2 synthetic targets, shall we say. But that's it's a little bit going backwards in order to go forwards. What would be much better is for us just to get a single message string from them, to just have range, bearing, and relative heading all in the same message. And the important thing from the DPO's point of view is that holds out the possibility of one button DP, where they can just go up to an asset, press the button, and they're straight onto DP. They don't have to hunt around or decide where the datum is, or so on and so forth. So that's one eye on the time there. That's what we're testing. There are some operational benefits which I've spoken about. So should we make the target selection part of the process? Should we make it an optional part of the process? I always like to leave the DPO in control, but if there is the DPOs are often being asked to do more and more these days, so if they can just rock up and go straight onto DP, that's of interest. And then is the additional situational data useful? And we've got some very interesting water column current data coming out of the Sonodyne sensor. Can we use that, bearing in mind that our models are designed for vessels like dredgers that have underwater forces working on them, FIFO that have underwater forces as they suck in and hose out water, dive support vessels that again have a dive bell that's providing an underwater force acting on the vessel. So there's a lot of vessels that would benefit from having the water column data coming into the DP models. Is that something we can do? And finally, I've got just a few questions for the audience, actually. Do these provide a different measuring principle? Could you have a SciScan targeted or targeted laser sensor and a targetless laser sensor as your 2 independent technologies. I believe you can, but I'm interested in what the industry thinks. How should we weigh each modality? How should we as a DP integrator, I know we leave it to the DPO, but we have to make recommendations, we have to set defaults in our system. How do we do that for these? And also, under what conditions do they break down? Because they're going to have their own failure modalities. How does the sensor communicate that to the DP integrator, and how do we communicate that to the DPO? So, just to conclude then, phase one, summer this year, we're doing trials through the summer, and Navis are going to be hopefully testing all those sensors I've shown you out there on the presentation. We've submitted a paper to do a presentation at the Marine Technology Society meeting in Houston in October to show our findings. So hopefully that will get accepted, and we'll see how that works out. And then late 2026, we're going to extend capability support for the Scene Scan, Unity, Sonodyne, Sprint. Now we're going to roll that out across the whole Navis DP set of fleets. So that's our plan. First trial is next week down in Plymouth. You're all very welcome to come and join me. It should be good fun if nothing else, and the weather's looking good, so that's a good point from a comfort point of view, but not necessarily a good point from a trials point of view, so we'll see how it goes. And then finally, these are new sensors. You're all going to have experiences of them out there. I'm just wondering how best to collate them. I'm personally very interested in these sensors. I was there at the start of the Scene Scan first targetless sensor. I've been watching Kongsberg bring out their response. I've been watching Furlong launch their response. I can see more sensors coming out, and I'm personally fascinated with this whole development. So if you have experience and information you want to share, please feel free to reach out to me. And then my plan is to win the OSJ DP of the Year award. So if you ever get an invite to vote, then please consider voting. Thank you very much.
Thank you, Andrew. Just wait for questions for you.
Okay.
Thank you. Thank you. Fascinating how we move into a new world of targetless sensors, removing potentially work on platforms and other things so it's all done from the vessel. Any questions for Andrew while we have him on stage? Nothing? Anyone? Oh, one, Chris here. Chris.
Hi there. Yeah, great presentation as they've all been. I'm Thomas from Intermoor, so we mainly do anchor handling, that sort of thing. I'm just wondering, with these kind of systems, if you have multiple vessels working around the same asset, is there any chance of interference and interfering with each other?
That is a great question. Like all sensors, if they're set up correctly, there's no chance. But of course, if they're not set up correctly, there's every chance. So I think that the really important thing here is understanding the sensor. So the ones I've trialed, I think it's unlikely your anchor handlers, let's say you've got 4 anchor handlers working around a drilling rig. I think it's unlikely that they'll all be so close to the drilling rig as to occlude the scene. But let's say they were, then most of these sensors will give the DPO the option of cutting out parts of the scene. But if you have a DPO who doesn't understand that and who just rocks up and they've been told that it's a one-click DP and they just click it and they're onto DP, and your 4 anchor handlers have occluded the scene, then there is a risk. There is a concern that when you move, the vessel will move, the other vessel that's on that DP will move with you. So I think it's important that you understand the sensor and that you set it up correctly. But I think in that situation, you will find that most of these will be of benefit rather than of hindrance.
Yeah, it's fair. And I guess a lot will come out in the wash, so to speak, with the trials and things.
Yeah, and what I'm interested in is if you are doing some of the washing, please let me know, because we need to share that feedback widely.
Yeah, absolutely. Thanks a lot.
Thank you. Just look around the room. Any more? Any more? I have a question for you. In terms of up to date, what has been the experience in such like the higher sea states where we're seeing significant seas of 3 metres plus and the operation of these types of targetless systems in the upper sea states, for example?
So that's another very good question. Firstly, the technology is changing all the time, and these are algorithm-driven technologies, so even if your hardware remains the same, your software will be updated, so please make sure in any condition that you're up to the latest versions and latest installations. The truth is, it varies from center to center. There are some sensors on there which I know struggle with diagonals. So whether it's in a high sea state or a low sea state, when you've got verticals, it's no problem at all. When you've got diagonals, it's not quite sure whether it's gone up or down or whether it's gone sideways because it looks all the same to it. The later versions, the three-dimensional ones, really look at the whole of the asset, and I've never been in a high sea state, so I can't say for certain, but I am very confident that that will end up being their special source. I have seen trial data of one of the vessels moving away from an asset, and the vessel was turning, so the asset was disappearing, and they started their positioning off the whole of the asset, and they ended up just positioning off the tip of the flare stack that was going out the side. As the vessel turned, it was still holding position. It knew it had seen the whole asset, and it knew that that tip of that flare stack was attached to the whole of the asset, and it was still holding position. And that gives me confidence that in a very high sea state where you're moving around and you're going in and out of sight, it will hold position. But you can't be sure. You've got to remember they're taking one scan, and then they're mapping it to the next one. At some point, that algorithm, at some point, NVIDIA isn't going to work properly. The algorithm is not going to be able to map.
Only one of three. That's great.
Oh,
Thank you.
Sorry.
Thank you very much. Any further questions for Andrew while I've got him on stage? Nope. Great. Thank you very much, Andrew.
Thank you.